Well, hello. This is a video that deals with the binomial example, applying it to a situation that's not too far-fetched that you could actually see in the real world. If you recall, up to this point, I'm assuming that you've read about the binomial random variable and the distribution and so forth. But if you recall, if x is the binomial random variable and little x is the realization of the random variable, the probability that the random variable equals a particular realization is the number of combinations in choose little x times p raised to the little x times 1 minus p raised to the n minus little x. P here is a probability of success for a given trial, and n is the number of trials. You recall that capital X here, the binomial random variable, is the number of successes for n Bernoulli trials, trials that have only two possible outcomes, and P is a probability of success for each trial. Okay, so we want to work with this probability distribution function here for this problem. A researcher wishes to conduct a study of the color preferences of new car buyers. Suppose that 40% of this population prefers the color green. If 12 buyers are randomly selected, what is the chance that exactly 1/3 of the buyers would prefer green? Okay, so what we've got here, we're after this probability. The probability that 1/3 of the 12 buyers, i.e. 4 of them, would prefer green. That is the probability that we want. Well, you probably could use some ideas from chapter 6 to tackle this problem, but we want to use this binomial random variable technique to get to it. And the way to think about this is, if I let x here be the number of buyers who prefer green, then it makes sense that x is a binomial random variable with n equals to 12. That is, there's 12 buyers that basically, when they come up to this car dealership, you can, or wherever they are looking at cars, they either prefer green or they don't. And so it's a binary outcome for each buyer here. There's 12 of them. We're going to assume they're independent. And if 40% of the population prefers the color green, then not only is the number of trials 12, but the probability of success we're going to assume to be 0.4. In other words, the probability that any given person would prefer green over any other color. Okay, so x is binomial with these parameters, n equals 12 and p equals to 0.4. So with this probability here, it boils down to finding the probability that x equals 4. Okay, because x is the number of buyers here. And we've modeled it as a binomial random variable. So we can apply this binomial function. So it's n choose x, so we've got 12 choose 4 times 0.4 raised to the 4th power times 1 minus 0.4 raised to the 12 minus 4th power. So again here, n is 12, little x in this context is 4, p is 0.4. Alright, so this is a number of combinations here term. We've done this in chapter 6. 12 factorial over 4 factorial times 12 minus 4 quantity factorial times 0.4 raised to the 4th. Simplifying here, times 0.6 raised to the 8th power. And simplifying this term here, we have 495 times 0.4 to the 4th times 0.6 to the 8th. And it turns out that if you punch this into your calculator, you get 0.213. So this is that probability here. So even though the chance of a given person, that given person has 40% chance of preferring green, 4 of 12, the chance that you'd get exactly 4 of 12 to prefer green would be just over 21% here.